It's for example, if the data file is a sequence file, like the 1 megabyte, many of the time it's a sequence file, then we need to do such a same thing to address that problem. Is we can use the direct memory access. Direct memory access means if we just specify size of the data instead of doing the same thing that we discussed before, the interrupt-driven I/O, we can do it just one time and read the amount of the data directly to the memory. However, it looks like the simple, but it's not that simple because the operating system, computer architecture itself is the interrupt-driven, right? So everything is a stop. So when I raise my hand, then student will focus. But if you guys transfer the data or the sending information, it cannot be controlled. But it is allowed as an exceptional case, so we need to have the specific hardware. Okay, it's a hardware level problem. If we write this, the idea is simple to transfer the data, amount of data directly, but it's the operating system cannot take care of such a thing. Instead, we can implement another highway. Okay, from Bridgeport to the Fairfield only. Okay, directly send such a amount of the data. So that is the DMA. So direct memory access the control. We need to have something in additional kind of the highway, so conveyor belt. Okay, from here to the memory. So it's just a step that we explained. For example, if we transfer the C byte, okay, like the 1 megabyte instead of 2,000 times the I/O, so we can just start then reduce. Once we read the data from here, so directly send to such a data to the memory until whenever we read the byte or the block, reduce until C is equal to 0. That is the reason until C is equal to 0 is a completion. Okay, so nowadays most of the system use such a direct memory access DMA. So you probably see in the BIOS, the old version of the BIOS, whether you are going to use the direct memory access or not. But nowadays, as a default, most of the system uses such a direct memory access. Then, when you read, it's not only hard disk drive, any types of the input and output device. There are different types of the I/O interface. So we can characterize such a different types of them, like the character stream or block. Character stream, as I mentioned, like for example, the 10 megabyte, 1 megabyte file. So kind of we can consider it's a stream data, right? If you are using the Java, how can you read the file? It's a file stream. So as we discussed before a lot of time, what is the file? File is byte stream. Okay, it's not like the paragraph or the new line or the period. It's just nothing but byte of the stream. So because of that, I know because of the name, some of the students, especially beginner, is sometimes confused whether file is a really stream or not. It's a stream. So we can consider such a character stream. Or in the low level, it's a block by block. Okay? So it's a block by block. Or when you access the data, especially the hard disk drive, such a file data, it can be sequential or random access. Depending on the type of characteristic of the access type, it may be different. Okay, so it might be different. Synchronous or asynchronous. Synchronous, send the data and confirm, and next block or next bit, next byte will be sent synchronous. But asynchronous, just send. Okay, which one will be faster? Asynchronous will be faster, but we cannot. The guarantee is sometimes it may be possible lose, whether it's a different order. So you need to take care of such a thing, depending on the device. So some of them provide both of the asynchronous and synchronous, but depending on the device, it can be synchronous, it can be the asynchronous. Okay. And then I/O, the operating system provides such a kernel I/O subsystem on top of this. So from this one is the operating system level. Okay. So the one of the component of if you are building the kernel operating system, you need to have such an I/O subsystem on top of such a device program. You don't have to worry about the hardware, the specification, but at least you should have the driver program, or you have in your operating system, you need to implement such the basic default or the device program. Then you have the I/O kernel system. Application can access the device through the system library. Okay. Then finally, system library. Using the system library, you can access kind of the, as we discussed a lot, operating system is an interface. So you provide the user convenient way to use such I/O device. Okay. I'm going to skip that. This part is just basic information. So, for example, if you send the data like the specific device, so we can use IOCTL, the system library, for the low-level data transfer. Okay. And also we can use other. You can think about the file. When you access the file, after you open, you can get the file and put the write the file. So that is the similar approach, similar mechanism for any other I/O devices. I'm going to skip the network device. Clock and time. What about the time? What about the time in our? Is it really exist? The time? The current time is 11:40. Is it really exist? We define, right? Actually, when the sun is the turnaround, the one time, we consider that is the 1 day. Then divide by the 24, the unit is to call the hours or something like that. It's mostly the very subjective, the concept of the something. It's a time. What about the computer? In the computer, there's no such a thing. Okay? It has only something sequence of the event. Okay? So, the computer actually does not need the hours or the second or millisecond. That is purely the logical concept of the human, the time concept. So actually the computer has such a clock. Clock is not the clock. This one is just the periodic event. Okay, cycle. Especially the CPU cycle. So there is a specific I/O device like the computer. It's like the tic-tac. The tic-tac-toe, so like the 1/60 second. Even though some of the application provide the millisecond or the nanosecond or the microsecond level, that is the logical, the divide, like the logical precision of the time. The most of the system provide the 1/6 second, the event, so which is called the clock. Then we can consider that one is also I/O device. So that by using this one, we can calculate if that is exactly 1/60 second. So every 60 times, we will consider this is the second in the clock, something like that. Okay. And we have seen the asynchronous I/O. We already see this. Sometimes when we see the system library, I can understand what about the VE. VE is usually called represent a vector. Vector means it's the number of elements. Group of elements is considered as the vector. Like the vector space. Scalar space is the 0, 1, 2. You can specify the coordinate. But the vector space is the number of elements. So there is no specific position. It has something, just the group of the value. So similarly, whenever you see the VE vector system library is the group of multiple I/O. So when you read the data, the VE provide the multiple I/O using synchronous or asynchronous method. We talked about the double buffering before, so I think it may be okay. And the kernel I/O system provides other data structure for better performance and the other reason, like the caching. I mentioned many times the importance of the caching to speed the efficiency of the processing in any computer system. But what is spooling? Oh, by the way, before the caching and buffer, what is a buffer? What's the difference?
Faster to slower device. intermediate memory which is fast also.
It's, both of them are kind of in between. Cache is used for reuse, okay, to speed. Instead of the slow media, so we can always use the faster media in between, okay, but it's very limited, so we need to take care of such a, it's a cache. However, buffer means it's a different bandwidth, okay, so like this 1 megabyte, and this one is the 10 megabyte. So the router speed, the home Wi-Fi is a 10 megabyte, but the internet provider is 1 megabyte. So I cannot watch it 10 megabyte, the speed, the movie. Instead, if we keep the buffer is the in-between storage, keep until certain amount of data. Then I can read from the buffer, then it looks like the faster speed, but it's the delayed time. So that is the buffer. Like to think about the buffer area. It's a kind of faster student, slow student, buffer area. So that is buffer. What about the spooling? Have you ever used the spooling? Database?
Spooling.
Oh, yeah,
Spool is the database, like the Oracle database. What is a spool?
To redirect an output.
So start and keep all the data until end of spool. Okay. Similar, I'm not sure, but the spool is the printer spool. So what's the difference? The printer spool and the other I/O device, the storage. And the NAS storage is the structure. Spool, you can once you start, you cannot stop it entirely. Once you start the spool, until the end of the spool, you will keep all the output, all the data. Similarly, such a spool can be used for the specific device. Okay, it's different from the other device. Other device, so for example, when I type the keyboard, it's event by event, asynchronous. Okay, but we do not keep until beginning of using the keyboard or end of using keyboard. But the spool always once you start we process, take care of all the data, so like the printer job. Data structure. We already seen the. I think that's almost the last one. Power management is getting more important in the mobile device. The most critical issue of any types of the mobile device is the power, because the faster the device you want, the more power it uses. So that is the dilemma. Okay. So for example, I don't think it's always a good idea to put the fastest CPU or the fastest device, because it use the more the power, so less power. Also, no downtime. So computer is an electronic device. So computer is different from the other computer, which is analog the computer, like the old style, the computer, because it's a power. Without power, it doesn't work. So which means any computer system needs the power. That may cause the huge problem in case power out. You cannot use it. You may lose your business, you may lose your data. So most of the system, the IT department infrastructure has the UPS system for power management. It's unstopped. I cannot remember. So UPS. Anyway, so why don't you search what it stands for?
Uninterrupted power supply.
Uninterrupted power supply. Okay. This is an example of the such I/O structure in the Windows. I think that's okay. So that's pretty much end of the chapter 13. Okay, by wrapping up. Operating system is, anyway, it is true, without operating system, it is true we cannot use the computing power. Nowadays, the concept of operating system is getting more important, such as a big data system. If you are interested in the big data system, please be familiar with such the big data, the operating system concept. Many of them are used in to build the big data system. Operating system, part of operating system, like the file system or the memory management, like to speed up a lot of the, for example, the database system used directly memory area to speed up. And also the file system itself, like using the distributed file system. So operating system is not only for your personal computer or the laptop, but also it's definitely used for the general purpose on any other computer environment. So then, even though you are not going to be a developer of the ABC operating system, but in anywhere that you will use the operating system concept. Okay, so thanks so much throughout the semester, but it's not done yet. So you need to do the project, complete the project, and when is the demonstrate? You already did the demonstrate. If you missed any the demonstrate, please contact the GA as soon as possible. And if you missed any the homework or any issues, it should be taken care before the final exam. Then the last thing is the final exam. It is true. I don't agree. The final exam score reflects all your knowledge and experience and everything. But that's currently the best way in the classroom to evaluate your performance. So anyway, this is not the elementary school, even the elementary school. The evaluate using the test. Please let me know if there is any other way better than taking the exam to evaluate the student performance or the experience in the classroom. But unfortunately, currently, taking the exam is the best one. Our project itself, project better. If you really want, I can do the strictly apply the requirement and because during the evaluation, what is the most important part? Do you think? It's a fairness, okay? But sometimes the project itself can be the subjective, and also it cannot reflect all your effort to the output of the. What if you fail to compile? I did all my effort, but so exam is one of the fair way. Because of that, I really hate any plagiarism or cheating. Okay. So without cheating, without such a plagiarism, it will be one of the fair method to evaluate the student performance. So please don't even think about just study. Best way, read the textbook more and more. Okay, I know the textbook is almost 400-500 pages, but it's worthwhile. So please read the textbook and then cover the PDF file, the lecture note. Lecture note is not the primary material. It's definitely textbook. Then you can use the lecture note for your supplementary. Okay. Then if you took the most of my class, you can be easily answer the most of the questions. That doesn't mean your answer is correct, but so it's not out of our classroom scope. Okay, thanks so much. We will see on the Tuesday the next week. If you are interested to join the workshop for the NoSQL database, it's after the 12:15. Okay, thank you.